All right, we started section P.4 very briefly last time. We hit on what it meant to be a polynomial, and we talked a little bit about vocab, and then we did some addition and subtraction. So our polynomial looked like this. We talked about all those A's with the funny subscripts are just numbers. They can be any kind of numbers we want. They can be square roots, they can be fractions, not positives, negatives, whatever. The exponents, however, can only be integers, okay? In fact, only whole number integers, so 0, 1, 2, 3, and so forth. And then we talked about polynomials being named by their number of terms. I won't write them again, but one term was monomial, 2 terms was binomial, and 3 terms was trinomial. We've done these examples where we looked at degree being the highest exponent of the whole polynomial, and the coefficient of that highest exponent term being the leading coefficient, whether it's the first item in the list of items or not, okay? And then to simplify, we looked at addition and we looked at subtraction. So for addition and subtraction, it's all about simply combining like terms. When we had the subtraction, we had to remember to distribute the negative first, and then we combined like terms. So we are at the point where we're taking a look at multiplication. Now, there's lots of ways to think about multiplication, but it all boils down to the distributive property. One of the ways that you might have heard before is the acronym FOIL, F-O-I-L. F is first, O is outer, I is inner, L is last. That's perfectly fine. Occasionally I'll have students who will separate this in a different fashion and it'll sort of look like a rectangle, and they'll fill in details inside of a rectangle. Also fine. I'm going to show you one just because I'm thinking about it that I had seen one of my student teachers do that was kind of fun. And she made it look like a smiley face, all right? So we all should be smiling because it's Friday and it's a 4-day or a 3-day weekend, right? Extra day off on Monday. And so the smiley face looked like this. Do you see the smiley face? Yeah? Okay, so she made a smiley face. The idea being that we simply want to remember that there are 4 different terms we're going to get when we do the multiplication. So if we take the 2y, we'll do them in order since I sort of threw them in there. If I take the 2y and the 3y, what is 2y times 3y? 6y, and you guys even remembered the squared. That's great. And then we're going to do these. I know this is not the FOIL order of things, but we're going to do the last terms next. The -1 and then the 4 for our eyebrows, so to speak, or our eyes. -1 times 4 is what? -4. And then if we do the mouth below, we've got the inner part of the mouth. I've got -1 times 3y, which would be what? -3y. And then the outer terms, or the sort of bottom part of the smile, 2y times 4, it would be what? 8y. Now, whenever we do this, we should look to see if any of the terms combine. Sometimes they won't. It depends on how we began the problem, what the terms were originally, okay? So they don't always combine, but often they will. There'll often be at least 2 of the terms that we can combine together. And if they do, we should combine them. We also tend to write these in decreasing order of exponents. So the highest exponent we usually write first. So the 6y squared would typically be written first when we're writing our solution. And then the terms that have y in them would be next. So what's -3y and +8y? +5y. And then our last term in this one is a constant term of -4.
Now,
so this would be our solution.
You said that it went usually from decreasing order to 6.
Yes.
Does it have to be like that? Like, so if we put it in our math lab as 5y plus
6y squared minus 4, what will it do?
Change it? Or?
I'm not 100% sure. It might depend on the directions. If the directions talk about descending order of exponents, then it probably will kick it back out at you and tell you that it's incorrect. If it doesn't, I would be inclined to think that it would still accept it, but I don't know that for sure. So if it is kicking something back out at you, you might try changing it to that order where the order of the exponents goes down and see what happens. I just don't know. Okay. All right. This one looks a little different. What's different about 5 than we just did on 4?
There's 3 terms in the second one.
Yeah, there's 3 terms. It's called a trinomial in that second set of parentheses, right? So if you really love FOIL, all of a sudden you can't use it because there's simply too many terms to use it. FOIL, that acronym FOIL, only works when you have a binomial times a binomial, and this one isn't. So whatever way you decide to do it, just make sure you're catching all of the terms that you need to be multiplying out. The way I always think about it is to take the first term and distribute it first. So that's how I'm going to do it. If I take my x and I multiply by 3x squared, what do I get? 3x cubed. Very good. And then I can take the x and multiply by the middle term in that trinomial, the negative 5x, to give me what?
Negative 5x squared.
Yep, negative 5x squared. And then the x times the last term, which is a 2, gives me 2x. Right, good. So I'm going to get 3 terms from distributing the first term. And then I'm going to do the same thing with the negative 3, the second term in the first binomial. So I'm going to take the negative 3 times the 3x squared, negative 3 times 5x, and then negative 3 times 2. So we'll do that one now. So negative 3 times 3x squared would be what? Negative 9x squared. Good job on correcting the positive negativeness. Excellent. Now I have negative 3 times negative 5x. So I'm going to positive on that one, right? And then it's 15x. And then I have negative 3 times 2. Negative 6. Lots of terms. 6 of them, in fact, right? And some of them do combine. If we're going to go with order of descending exponents, the 3x cubed is already in the first location, so that's kind of nice. There are 2 terms that have squareds in them. I have negative 5x squared and negative 9x squared. What does that give me if I combine those? Right, negative 14x squared. So those are sort of taken care of now. I also have 2 terms that have x in them. I have a 2x and a 15x to give me 17x. And then there's 1 term left over at the end all by itself, which is a negative 6. Good to go? I had a 2x and a 15x, and 2 and 15 would be 17. Right here. They were both positives. Any other questions in that one? Okay, what makes 6 look weird? Yeah, the square roots. And you might even look at this and say, and there's also no x's in it, right? I mean, that's okay. It didn't have to have x's, but the square roots certainly make it look like this is somehow more challenging than the ones we've done before. It is kind of nice, though, that this is a binomial times a binomial, right? There's 2 pieces added, and there's 2 pieces added. So just for the sake of saying we've done one with FOIL, we'll do FOIL on this one, okay? FOIL says that we're going to multiply the first terms together first. So what is 5 times 4? 20. That's my simple one, right? O for outer says we're going to multiply the outer terms next. So that's the 5 at the beginning and the negative 3 square root 2 at the end. Now we worked with radicals last class period, right? We finished up working with them, in fact. So when you're talking about working with radicals, if it's underneath the radical, it gets multiplied by whatever else is underneath the radical. And if it's in front of the radical, it multiplies by whatever else is in front of the radical. So when I'm working with the 5 here and the 3 square root 2, which numbers are actually going to visibly be multiplied? Like you're going to see it happen. The 5 and the 3, because they're both outside of a radical, right? So 5 times 3 would be 15. And then the square root of 2 is still just the square root of 2, because there is no other underneath of a radical to multiply it by.
Would that be negative 15?
Yes, it would. Thank you. Keep me on my toes. Watch those signs. Fantastic. Negative 15 square root 2. All right, so those are the outer, first in the outer terms. Let's look at the other 2 pieces. We're going to do the last terms together, or inside terms together. So FOI for FOIL, these are my inside terms. I have a square root of 2 and I have a 4. So what will that be when I multiply those 2? Right, 4 is on the outside, square root of 2 is underneath, or the 2 is underneath the square root, so it stays there. And then our L for last terms would be, I did them out of order and nobody stopped me. First, outer, inner, no I didn't, hang on, last. These are the ones I want, right? There we go, get them marked right. I have a square root of 2 and I have a 3 square root of 2. Okay, so the only number that's on the outside is the 3, agreed? And let's see, I'm going to have a negative. And then I have square root of 2 times square root of 2. Well, that's square root of 4, right? But what is the square root of 4? 2. So if you want to write down square root of 4 sort of as an intermediate step, you can. If you don't need to see that because you saw it initially already that this is supposed to be 2, then just write down the 2 and you're good to go. So I have 3 times 2 for my last term. So let's combine what I've got here. I've got a 20 here, and I've got a negative 3 times 2 here, which would be negative 6. So 20 minus 6 is 14. And then the other two terms happen to both be like terms, not identical, but like terms as well. They both have square root of 2 in them. So I have 15 square root of 2, and I have 4 square root of 2. The 15 is negative. So what would I get when I combine those? Negative 11 times square root of 2. Excellent. And I can't combine those because one has a radical and the other one doesn't. Right? All right, cool. One more problem. We encountered this phrase last time, rationalize. And we talked about rationalize meaning that we're going to get rid of radicals. That's the idea. Simplify it so there's no radical present. Now, for the most part, we rationalize denominators. There are a couple of points I can think of in math, but it wouldn't be something we would do this semester, where you might rationalize the numerator. But most of your directions are going to say denominator, all right? So we're going to rationalize the denominator, which means I don't want, in particular, the square root of 8 here. It's not what I want. Yeah, so one of the things that you could do first is you could simplify square root of 8. We're going to have to simplify it somewhere along the way anyway. The second thing you could do is you could deal with getting rid of the radicals first. And I don't necessarily care which one we do, so what would you guys like to do? Simplify the radical 8 first, or get rid of the radical in the denominator first? Simplify it first. Okay, so if I simplify my radical first, my numerator is not going to change. So please remember, we talked about this a couple of times already. Keep writing all the pieces that you're not manipulating. They're still a part of the problem so that you don't lose them. How does square root of 8 simplify? 2 square roots of 2. And of course, if you'll remember, if you're looking at that and going, how did they get that? All we're doing is breaking 8 down into 3 2s. 2 of them match, and so those get pulled to the outside. Okay? All right, so at this point, my radicals are simplified, and I'm going to rationalize. Now, the rationalizing denominator I did last time was easier because it just had a radical in the denominator. It didn't have the addition of something else to it. So once I have the addition of something else to it, it makes it more complicated. I can't just multiply the denominator by square root of 2 or 2 square roots of 2, because if I do, then that means that this 3 at the beginning will then have a square root of 2 attached to it. And that's not what I want. I don't want the square root of 2 attached to anything. So does anybody remember the sort of trick for multiplying to get rid of the radicals in the denominator when you have addition or subtraction?
Don't you multiply it on the opposite side? So it'd be like negative 3 plus square root of 2.
Okay, so is it Andre? Okay, so Andre is suggesting that we multiply, I think, by this. Is this what you were suggesting, Andre?
I think you put the negative on the outside.
Okay,
Or not.
you don't, but you're so close, yeah? This is the correct thing. Does anybody remember what this is called?
Reciprocal.
You're close, not reciprocal. Reciprocal is when we flip a fraction upside down. Any other guesses?
Inverse.
Also inverse, very close. Not this one. It's called a conjugate. Have you heard it before? Maybe you haven't. It's okay. It's called a conjugate. The conjugate is the binomial that matches the one you have, but the sign is switched in between. Now, this is a fraction. You can't just go multiplying portions of the fraction by whatever you like. That would change the value. What would I have to do to compensate for the fact that my denominator is now being multiplied by 3 minus 2 square root 2? Multiply the top by it as well. Okay, so in a fraction, whatever I do the denominator, I must do it to the numerator. And now you can see that the last example we did over here, right, is necessary. You got to be able to do it again, right? You got to be able to multiply out with radicals. So let's take a look at what we get for this. We will do the numerator first, just because it's on top. We need to do first, outer, inner, last, or distributing, or smiley faces, or whatever you want to call it. If I have square root of 2 times 3, what do I get? 3 square root 2. Outer, if I have square root of 2 times times negative 2 square roots of 2. Well, the negative 2 on the outside stays, and then what happens when I multiply the square root of 2 times the square root of 2? It's just 2. Square root of 2 times square root of 2 would be square root of 4, and the square root of 4 is simply 2. So my outer term actually ends up being 2 times 2. All right, the inner terms. That's a terrible color. I need a different one. How about this one? That's also terrible. That one will work. All right, so my inner terms are 5 and 3, so 5 times 3 would be 15. Fantastic. And then my last terms would be the 5 times the negative 2 square root 2. What would that be? Negative 10 square root 2. All right, if that's your phone, go ahead and get it turned off for me, please. Is it coming from up there? No, okay, sorry. All of a sudden it looked like it was coming from the ceiling, and I thought, is it my iPad? That would be highly unfortunate, wouldn't it? Okay. All right, we're going to take a look then at the denominator. Now, the denominator has something really cool going on. There is a reason that we chose to multiply this thing called a conjugate. And of course, the reason was we wanted the radicals to go away. But they go away in such a fashion that makes the denominator's multiplication very easy. So raise your hand if you've heard the phrase difference of squares. Okay, I'm not going to put you on the spot and say what is it, just if you've heard it. Okay, most of you probably heard the phrase difference of squares before. This is a difference of squares. Here's the cool thing about what we did in the denominator. Look at the outside terms. I have 3 times negative 2 square roots of 2. And look at the inside terms. I have 3 times 2 square roots of 2. What's going to happen to the outside and the inside terms? They cancel out. They're going to be the exact same quantity, but one of them is positive and one of them is negative. And that always happens when you have conjugates. Always. And that's why we like them. Because the inside and the outside terms cancel out. So when we're working with conjugates, the only multiplication we really have to do are the first terms and the last terms. So the first terms here are 3 times 3, and that would be 9. And the last terms here are negative, because one of them is positive, one of them is negative. And it's 2 square roots of 2 times 2 square roots of 2. Okay, so the 2's on the outside get multiplied, and you get a 4. And the square root of 2 times square root of 2's get multiplied, and you get a 2. And you have no more radicals in the denominator. Beautiful, just beautiful. All right, we're going to clean up the numerator. Since it's listed first, I'll list the radical parts first. I have 3 square root of 2, and I have negative 10 square root of 2, which gives me what? Negative 7 square root of 2. And then we have negative 2 times 2, which would be negative 4, plus my 15, which would give me 11. And then in the denominator, I have 9 minus what? 8, which is a wonderful number. Yes, otherwise known as 1. So I can write this. This would be an awkward way to sort of leave anything written, obviously, because division by 1 doesn't change the value. This expression simply becomes negative 7 square root 2 plus 11.
Does the order you put the numbers in really matter? Could we not put 11 at the front?
You could put 11 at the front. That definitely does not make any difference. So if you put this in my math lab, I know it will accept both those answers. Yes. Good question. Also, make note that it doesn't always give you a 1 in the denominator when you multiply by conjugates. That just happened here. Okay, so radicals always go away, but you don't always get a 1. You might end up with a fraction still going on in the problem. Any other questions on this one? All right.